everybody. In this tutorial, I'm going to show you how to generate your Gerber files effectively using EAGLE PCB. So I have EAGLE PCB open up, and basically we're going to browse to a project that I will be showing this an example. So right here I have a flashlight schematic that I created. So basically Gerber files are files that you send off to the PCB fab house to get your PCB board made. So you don't want to actually ever send out your CAD files because it might contain important or sensitive data that it's for, like, say for IP or anything confidential, which could be bad to send. So you send them off your Gerber files. So Gerber files are essentially an image of your board, but without any thing that the fab house or anyone is unable to edit. So in this project, we have a 2-layer board. So the top part is red, so that's the top layer, and then the bottom layer is blue. So I just opened up my layers tab right here, so we can view everything that's actually being visible. So we have our top layer, bottom layer, pads and vias. So pads and vias are always represented with green by the default settings. And then our unrouted, so that tells us if we're missing any routing, so it'll show up as aka air wires. And then our T places, T origins, T names, those are all the the texts and stuff you'll see. And then the other layers. So this is up to 52 different viewable layers we can see on this 2-layer board project. So this is important to understand how the layers work, because this is what you're going to be exporting when you're going to be generating your Gerber files. So when I generate Gerber files, I like to have the EAGLE window open, and as well as the Gerber generator window open as well. So we're actually going to have our EAGLE project on my left side of the screen, and then we're going to actually open up the CAM processor. So we go to File, click on CAM processor, and then now this window opens up. So we're going to expand this window a little bit more, and then now we can view our job selection where we're going to actually be generating Gerber files. So of course this is default setting. I know we don't want to use this. So we're going to go to File and then open up Job. So Job ends in .cam extension. But first we need to actually download a CAM file job, because it will actually make generate Gerber files a lot easier. So we know all the file extensions and what kind of version we want to export it to. So we're just going to fire up Firefox right here, go to Google, and then we're going to use the CAM file from SparkFun Electronics. So I'll just type in SparkFun Electronics EAGLE PCB CAM file. So then we're just going to go to the first link up here. Let that load for a sec. The internet's a little slow right here. So then we're just going to go download this third file right here. So SparkFun CAM file. So we'll just do a save link as, and then just download to the desktop. Download to wherever you want, as long as you can find it, because we're going to browse that file when we have EAGLE with our CAM processor open. So we'll just close out of Firefox. Now we're going to go to File, Open, and then we're going to browse to Job. And then I already have a bunch of CAM files saved from previous projects, but we'll just ignore that for now. So go to Desktop where I saved it, click on this file, SparkFun Gerb 274x.cam. So this is generating the version of Gerber files. There's different versions of generating Gerber files, but this is a pretty standard one, RS274X. So that's a pretty standard one. So we have these different tabs up here, and you don't want to, these are just standard for a 2-layer board. So we have our top copper, so extension GTL, so Gerber top layer, bottom copper GBL file extension, and then top silk screen, this is where you see your text and everything right here, so the white color. Top paste is where it defines your pads and stuff, so GTP. Bottom silk screen is obviously on behind the board. And then top solder mask, that's also related with how your pads are going to be defined, so it doesn't actually, so the fabricator knows not to cover your pads, and you'll have something to solder on. Then your solder mask, and then your drill file. So we're going to be using Epsilon drill files. Those are pretty standard as well. And then mill layer, that's just a suggestion from SparkFun that allows you to know the outer perimeter and just for anything milling and cutting. So the tabs we're going to actually be editing are just going to be mainly the top silk screen and the bottom silk screen. We can leave everything else as is, but however, I want to make a modification for the bottom copper. So we want to select dimensions, as the dimensions already selected on top copper right here, as you see. So dimensions is this outer border right here. So if we actually hide the top and bottom layer, so layers 1 and 16, hit apply, and then we view this little box right here, we can actually see that this is on the dimension layer. So it tells you how big your board is. So if we click on PCB quote, we can actually find the dimensions of our board. So it's 0.6875 inches by 0.725 inches. So if we go to our mouse right here and then we just go up to the corner right here, we can see the exact dimensions. So right here and then right here. So the PCB quote is defined, or defines your board size off the layer 20. So we have to actually export that when we're generating Gerber files, so the fab house knows how big to cut your board. So that's important to have layer 20 selected with top and bottom coppers. So this is a tricky part that a lot of people have trouble with, generating your silk screen. So we're just going to turn the top and bottom coppers back on. So by default, top silk screen is selected on T place, but that's not always correct because it depends on how your libraries or packages were made for EAGLE. So we can actually view what is actually on T place, so layer 21. So if I, right now we see that layer 21 is on. So if I just unselect 21 and hit apply, we can see that a bunch of text is on layer 21. So we see that C1, L1 inductor, ground, R1 and R2 and V and C2 are on T place, so layer 21. So just to view that again. And then also for behind, so B place right here, LED flashlight, I've set that to layer 22. So if I hit apply right there, then we see that the back text hides. So that's behind the board, as well as the LED legends. So if for some reason yours is not on T place, and sometimes this might be on like B names or something, so if there's an issue with that, you just simply go to right click on the text right here where this little crosshair is right here. You also need to have that enabled to show, so you'd have to actually have layer 23 and 24 selected. So you just right click on that, go to properties, and then you can view what layer your text is on. So sometimes you might put it on B names. So I can just actually, just for organizational purposes, I'm going to put everything on T names and B names. So just to make this tutorial a little more effective. So I'm going to put that on B names, and then I'm going to any text I wrote is going to be on names layers. So I'm going to say right click on C2, put that on layer 25, so T names. So I'm just going to do a shortcut called info, and then just click on that so I don't have to keep right clicking. And then go to T names, hit OK, and then go to layer 25, T names. I'm going to do it for all of the top side of the board. So give me a second to do that. I'm almost done. And then one more. Alright, I believe I have all of them. So now if we hide layer 25, so T names, we can see that all the text disappears. If we don't want the silk screening, like let's say for this microcontroller, the LT controller, we could actually hide that, so T place, so hide that. So why would you want to hide some of the layers when exporting the Gerber files? Well, one rule is you can't have silk screen on your pads because you won't be able to solder. So if you have C2 on top of this pad right here, sure, it might look nice, but when you actually get your board made, you won't be able to actually solder because it's going to insulate it's not going to allow your solder to stick to the pad. That's pretty much as simple as I can say it. So sometimes your IC, depending whoever made the package, might put that on a different layer. So let's say that you have this little box around this thing. I think it's on, for this IC, it's on T-Docs. So right there, you have this little box right here. So right here, if we export that to Gerber's, you'd actually have all this cover on top of the solder, on the top of the pads. So that's a no-no. So if you, let's say you don't want to export T documents and everything just disappeared, but you need to know polarity, all you could do is you just type in text and you just put like a little period or something. So I'll put a little period right here. And then you can place that period right here. So you have this period right here, and then you're going to go to properties and you're going to change it to your appropriate layer. So we'll just change this to T names, or yeah, right there, T names. And then we'll adjust it to vector font because we want that's important to use for fabrication. So what you see on the board is what you're gonna pretty much get when you're back from the fab house. So we'll make this a little bit smaller, increase the ratio, that's the thickness, so like making it a little more bold. So you want at least a minimum of 12%. And then now you have your little period right here. So this period indicates like which is notch 1. So as you can see, this little marker right here, this is for notch 1. But I already did this in this package, so it's fine. So we need this, but for some IC packages, you're going to want that because as again, you can't have silkscreen on top of the pads. You can have them on top of traces, which is fine. So now we know which layers our Gerber files, our layers are going to be, so we can generate our Gerber files. So top silkscreen, we want T-place because we want the little outline for this IC, as well as we want B-place for the outline for the bottom LEDs, as well as for the text. So we're just going to select B-place, and then we're going to check T names and then B names. So we're going to verify that everything is not overlapping. So we go T names, apply. So that's good that we have that selected. And then B names. So that bottom text should be disappear. Now we'll put it back. And we're going to select T-place, make sure that that solder silkscreen is fine, and B-place. So everything looks good. So we have these selected. We have bottom silkscreen. Actually, I made a mistake. So top silkscreen. So we only want this for T right here. So unselect B-place and then B names. We're going to switch that over to bottom silkscreen. My bad about that. Sorry about that. So we want layer 22 selected, and then B name, so layer 26. So this is the extension of GBO. So bottom silkscreen, top solder mask, and these ones leave alone. Your Joe file is gonna be a text file, so make sure to send that off to the fab house as well. So we have all our Gerber files selected. So see top dimensions. We want dimensions for all the copper stuff. So now when we have everything selected, now we're going to go to process job. So since there's no browse, it's just the extension, it's going to save exactly where your project is saved. So if I just go to documents and I just open up EAGLE, this is where our flashlight is right here, see? So if I actually click on process job, we're going to generate, we want to save this board right here. Save it. And now all our Gerber files are generated right here, see? So, I mean, sometimes the file extensions are a little confusing. So then what you do is you just go to details. You can do via detail pane view for your Windows Explorer Finder. Click on date modified, and then you can see where all your recently modified files were. So BRD is just your board extension, and .ch is your schematic. So we're going to select everything but those extensions related to that. So we're going to select all the way from DRI all the way to text. So for this board, we're going to have 11 files selected. These are the only files you need. We're going to cut, and then we're going to make a new folder on the desktop. So let's do it over here. So you can see the folder. So I'll just call it flashlight Gerber. And then we're just going to paste our files here. So now we can close out a CAM processor right here. I'll save the job. And then now we're going to open up our Gerber file viewer. This one is called ViewMate from Pentalogic. It's a free program. You just have to register on the site and you can download for free. Of course, some of the features are limited as it is a paid program, but it does a basic job of viewing what your Gerber files are going to look like. So if you generate your Gerber files, your files should look exactly to this board. So we're going to hit rat's nest so we can view the copper pores and everything. So top copper is red, bottom copper is blue. So now we're going to go to File, Import Gerbers, and then we're going to go to Desktop, and then we're going to go to Flashlight Gerbers. Select all the files, so all the 11 files, import. Ignore this error because this is relaying with drill files and stuff. So now we have our view of our Gerber files. So it's just essentially an image of your CAD files that no one can modify. So we'll just expand this pane out here, and then we're just going to start unselecting everything, and then I'm going to reselect everything just to view, make sure that it matches up with our layer in Eagle. So let me just make this a little bit smaller. So now we're going to hide everything, so none, and then we're going to view our top layer right here. So our red right here. Oh yeah, and we also want dimensions viewed because we exported that with the top copper. So click on GBL, and then we have our exact same image of our, oops, this is bottom layer. I want top layer. GTL. So top layer, and then we can see that this is exactly the same as your what you're viewing in Eagle. So now that looks very good. So I'm just verifying that everything is good. We want to verify that no traces are too close to each other. Right here you see these little gaps. These are called thermals. So this will help with heat dissipation, especially it will help with soldering the components. Makes it a little bit easier as your components will expand a little, the pads. So moving on, we're going to select our bottom layer and hide top layer while dimensions is still selected. So unselect this. Now go to GBL, so a bottom layer right here, and we see that it is exactly the same view right here. Of course, you see these little dots right here. This is related to your holes. So we actually need to export that when we want to view holes on here. So we, pads and vias, that was exported standard with your top and bottom layer. But it's not too important for right here. Because, you know, it's your holes are going through the entire board, so they're going to be plated and it has to reach the top and bottom layer. So that's why it's not too big of a deal to worry about that. So then GBO, that's just our bottom silk right here. So this is right here. So if we just hide their bottom copper, and then we just go to B values, and then start B values, layer 26, B names, and then B place, we can see that our text is right here. It shows up perfectly. So everything's looking good. And then now we're gonna go to GTL, so our top, not GTL, GTO, our top silk right here. Hide that, and then we're gonna hide the bottom text, and then we're gonna show the top text. So we see that this looks exactly the same. So we have our, this is denoted in yellow, this is denoted in white. So we see that it's in the same position and everything. So we're doing good. So I've generated the files properly. GTP, this is just top solder paste. This is related with the pad cutout of the pads, and then GTS, that's also related with the cutouts of the holes and stuff. So we'll just have everything selected normal, and we can just verify that everything was properly produced. So we want these ones selected. Alright, so this is our board. So let me just hide this polygon. So I just hit the little rip up button right there, and then I'll just hide the bottom layer. I can, oops, I want the top layer to show, the little rip up command, and now we have all our stuff back. So this prevents you from actually having to close the EAGLE program. So we see that everything looks good. So now you have all your Gerber files, and I've verified that everything looks good. So proper Gerber files have no text or your silk screen covering any pads, and you have your dimension layers. as well as it needs to match where your Eagle or your board layout is. So then we can just close out of this, and then now we have our flashlight Gerbers, and then we're just gonna right click on this, and then we're gonna zip it up. So I use WinRAR, and I can just go to Add to Archive. I mean, I can delete the files because I don't need them anymore, and I just want the zip file. And then we just go to zip it up, and then we can just send our file off to our fab house. So this is generating Gerber files in EAGLE CAD effectively. So these same these same steps can apply almost to any PCB software. It's just a little bit different in EAGLE, but you pretty much will have the same file extensions for the other PCB software such as Cadence, KiCad, Altium, and stuff like that. So yeah, thank you for watching, and I hope you found this tutorial helpful.